More time. Thank you.
You are on the roof of the physics building, 46 meters above the ground. Your physics teacher, who is 1.8 meters tall, is walking toward the building at a constant speed of 1.2 meters per second. If you wish to drop an egg onto your teacher's head, where should they be when you use the egg?
All right. I'm thinking about it. Would you mind reading again? No offense, but please read it again, just so I can write this stuff down while you're doing it. I'm drawing a diagram.
You are on the roof of the physics building, 46 meters above the ground.
Okay.
Your physics teacher, who is 1.8 meters tall, is walking towards the building
Would you say 1.8?
at a constant speed of 1.2 meters per second.
V equals what?
1.2 meters per second. 1.2 meters per second. If you wish to drop an egg onto your teacher's head, where should they be when you
My TAs are the loudest people. I'm just saying. Oh, I didn't get a smile. What'd you say? Oh, sorry. I didn't mean to offend you guys. Go again. What am I missing? What info am I missing that you got in the problem? Oh, man. So, I mean, does it matter that it's an egg first? I mean, water balloon, pie, anything you can grab, right? Yeah, piano. Let's just talk strategy. If you know the height that the thing has to fall, now what height do you use? Why don't we just get that out of the way? 46 meters minus 1.8 meters. And what's that? I need your help calculating stuff.
44.2.
Okay. 44.2 what?
Meters.
All right. All right, and this is how far egg falls. Yeah, no.
Do you know the height of the student dropping it?
What are we assuming about the droppings?
Drop it from building height.
Yeah, we're dropping it like right there, and then it speeds up. I'll do a little baby motion map. You guys cool? So it's gonna do that. What direction do you want to make down? I mean, yeah, that's a good question. What direction do you want to make down? Down. Ah, how about what direction you want to be positive?
Down.
It doesn't matter, right? I like down positive here because you got acceleration down. Okay. So, I don't know. I like velocity graphs. That's how I'm going to do it. You could do this so many ways. So, velocity in the y direction for the egg. Does the egg start from rest? I love that. That makes things so much easier. Yeah? It really does. So your velocity graph then looks like this, right? And, please put units. All right. And your acceleration graph, therefore, looks like what? Notice we made up, down positive. So our acceleration graph, what? Oh. Straight horizontal line. All right. And this area is what? Okay. Change in velocity. And in this case, it equals final velocity because V naught is 0. Okay. And that equals AT. Everybody good so far? Okay. And then this area, we don't know T, right? But we know what that area is. Yeah? This area is this. Yeah? You guys happy so far? Yeah. Okay. And our final velocity is A times T. Can I call A 10?
Yeah.
So let, okay, I'll use 10 then.
No, 9.8.
Who wants 10? Raise your hand. Who wants 9.8? Sorry. Haha. It's okay. You can, hey, everybody's free to use 9.8 if they wish. It's okay. Meters per second squared t, right? And I'm just gonna write this as 10t. So my final velocity is 10t. I'm writing it because I don't have that much space there and it gets stupid real quick. Okay. So that area must be 1/2. What? 1/2 10t times t. Yeah. And then times another t. I'm gonna call that t. So let t equal time to hit bald spot.
Did you say bald spot?
Yeah, right here. That's what you're aiming for. I thought it was funny. Time to hit. I really thought it was funny.
It was really funny.
Nobody laughed, but I thought it was hilarious. If you actually had hit that, that would be funny. Like I've been hit on the way to school, on the way to the bus. I've been hit by projectile objects, like from flying creatures. And then instead of getting on the bus, I just went home. I was like, I can't go on the bus. This just happened, and I actually missed a day of school once because of that. Anyway. All right, so let's get this thing wrapped up. This equals 44 meters. You guys good there? And so let me continue over here. 1/2 10t. T equals 44 meters. Okay. It's just algebra right here. And all this gives us is the time to hit homie on the head, right? That's all it gives us. So let's figure that out. We got 5t squared equals 44 meters. And you can play algebra game on your own. What's t? Help me. Somebody's done this, I bet. I mean, look, it's almost 9. It's about 3. It's about 3 seconds, roughly, right? I mean, 44, let's pretend it's 45. You guys cool? All right. So, time to hit head, top of head, after being dropped. I don't think it's really a question of quantity of problems for some of you guys. I think it's a matter of doing a few problems really well. That'll prepare you the most. Do you understand what I'm saying? Every answer you get, what does it mean? This will help you. Okay? Help me. It'll probably help you. Now, if I go back up, I haven't solved the problem yet. What did we want to find? How far? What is meant by that? How far? So how far he is from where? All right. So here we go. Wait till it's really quiet. Because I'm trying to think of a clever way, but probably just going to be a stupid way of doing it. Why don't I do this? Let's model this dude's motion. What is his motion? You can never go wrong by just simply going back to the basics. What's that area? Okay, lost some people here. This is constant what? So this is like your battery-powered vehicle was, right? Okay. So if I take this area V times t. I have V. Do I have t? What do you mean? Do I have the time it takes the egg to fall? See, some of you didn't reach the realization that the time the egg takes to hit the ground is the time it takes homie to walk towards the building. That louder. I think you're right. Let's so 1.2 what? So that's his velocity. I'll put that there. Put units. Let's clean it up a little bit, make it look pretty. But I think essentially you're probably right. This is 3. I think you're right. So 1.2. We already have the units here. I'll make a deal with you. Put the units on the graph and don't worry about it so much in your equation. Deal? 1.23. That's meters per second times second. Does that give us meters?
Yes.
It needs to, right? Meters per second times second. Okay, what's this going to be? 3.6 what? Okay, are we making to the right positive? So let's say this guy's at 0 right now, and we're making to the right positive. You guys dig I'm adding this in? That makes this positive.
Is that changing velocity or
It would change in position. This is change in position for person.
Position 0. That is.
Now, if the question asks what exactly?
How far?
How far? So, how far does he need to be? Done deal. You guys cool? Last call for questions on this one. Happy?